Hi, my name's Siddharth. I'm going to be presenting on the circuit for bonus points that myself and my partner designed, which is the fan regulator. So our circuit idea, many dorms at Purdue have no AC and houses too. So we decided why not build a circuit that regulates a fan based on the ambient temperature. So the hotter it is in the room, the faster the fan spins, and likewise, as it gets colder, the fan will spin slower. This can conserve power and make the room more consistent in temperature. Here's the way that we did it. So we used a voltage divider with the R1 being a thermistor. This is a temperature sensitive resistor which changes resistance based on the temperature that it's feeling. That was the R1. The R2 we set to 100,000 based on our calculations that would work well with the 47,000 ohm thermistor that we had, and that's in parallel with a light. In our case, we used an LED. The reason we used a light is because there's no motor included with our kit, and we both don't have access to the ECE shop. If we were to replace the light with a motor, it would have to be a brushed DC motor. I believe brushless DC motors have some more like they need a signal, and you can't just apply a constant voltage to them. So with a brushed DC motor, you could control that using this circuit. Here's the constructed circuit. As you can see, we have our thermistor right there, which is that little black thing, and then the light and resistor 2 are in parallel with it. So here you can see the usage. On the left is it at room temperature, and on the right is me with my finger on it to make it warmer. So as you can see, the light did get brighter. It didn't get a whole lot brighter, and I'll explain why this is in a little bit. But you can see that the voltage going across the LED does increase as the temperature increases. For some reason this video didn't work in the slides, so I'll just play it here. As you can see, I'm putting my finger on it, and if you observe the DMM up top, you can see the voltage is increasing. That voltage is measuring the voltage across the LED. So it peaked right around here, and as I let go, again, the voltage drops. Now it loads, okay. So one question might be, why is the light so dim? So the thermistor included in our kit is 47,000 ohms, but the resistance of the light, in our case the LED, is a lot less. So this creates that situation where the resistance of the load is a lot less than the resistance of R1. And so this causes the thermistor to use almost all of the voltage, and so very little voltage is actually dropping across the LED. And for that reason, the light is dim, and the voltage change is also very small. So if we were to use a smaller thermistor that wasn't as big as 47,000 ohms, this problem would be greatly reduced. So in conclusion, we've designed and constructed a very basic circuit that regulates voltage based on temperature, which could be useful to control a fan like a thermostat. As it is, with the limitations on parts, it couldn't be used to actually usefully regulate a fan. But if we use the same schematic and just swapped out the values of the thermistor and the lights, it could be a useful circuit. Thanks.